So now in part 2 of section 9.2, let's continue with some exercises and multiplication, and the multiplication property and also permutations. So first, question number 5, we have that teams A and B play until one wins 2 games in a row or a total of 3 games. So let's draw a possibility tree that is going to give me all the possible sequences. So, and with that, we can probably get how many ways the tournament can be played. So we're going to get the start here, the start point. And we're going to assume that in this direction, A won one game. In this direction, B won the first game. So this is the first game. So now, the second instance is like, well, A might have won the second game, right? And so this will mean that we have an AA situation, 2 wins in a row, and so A will win. And this will be the end for this side. We can also have the scenario where B is going to win this game. So we're going to have A and B. They have 1 game each. One each. And so it's this condition where we have A, B. Now, from this point, a couple situations can happen. We can have that B wins again. So we have A, B, B. So this is essentially a B win because it's 2 in a row. Or we can have the situation where we have A, B, A. And so with this, no one wins yet. Because we don't have neither 3, neither 2 in a row. So we can have another situation is at this point, we're going to have that B is going to win 2 more. Like at this point, we can have A, B, A, and let's say B won twice. So this will be a B win situation. Or we can also have the sorry, let me just this is probably not the best one to go here. Since we already have that A won twice, the next situation that can happen is that actually we have that A wins 1 more. And so this will be a win for A because it will complete 3 games. Okay? Which will be the next step. Then the next situation that can happen is, okay, so instead of winning A, it wins B. So we have this situation. And then we finally end where B is just going to win 2 times. Okay? And so now, we end up having this situation. Or, of course, you can have the situation where finally you have A, B, and then A wins at the end in the last game. And so this is an A win. And this will be a B win. Okay. And so now that is starting from the point where A just won. But now you can have from the start where B won the first game. Of course, you can have the B, which is 2 games for B. And so this is a B win. Right? Or we can start by BA. And so with BA, there's a couple of possibilities. And is, of course, A wins again. So BAA. So this will be an A win. Or then you can have BAB situation. And so once again, the possibility to finish this out is that we get BABB. And so now B is 2 in a row. So this is a big win. Or we can have the situation where once again we get BA, BA. And so there's only two possibilities here, and is we're gonna get BA, BA, B, which is a B win. Of course, we're gonna have BA, BA, A, which is an A win. Okay, so in all this sequence, we have two sequence with two games that are wins. So two games wins. We have this situation. We have three games with wins, A, B, B, or we can also have B, A, A. Those are the opportunities where they win. For four games, we have the possibility like this, where we're just gonna win with four. So we have A, B, A, A, or we also have the B, A, B, B. And those are the opportunities that we're gonna have for four games to end. And now with five games, which seems to be the last possible, then we have A, B, B, A, which is three wins for A. We also have the A, B, A, B, B, and we have the B, A, B, A, A, and the B, A, B, A, B. So in general, counting the total, notice that this is 4, 8, 10 total. 10 total options on how we can finish the tournament in total. So these are 10 possible sequences that are going to give me the tournament. Now, assuming all ways of playing are equally likely, what is the probability that 5 games are needed to determine the winner? So 5 games are this here. So the probability of 5 winners, 5 wins, it gotta be, or 5 games, sorry, not 5 wins. 5 games. Gotta be what? It gotta be 4 out of the total of 10, which is this. So simplifying, that will be 2 over 5. All right, so that's more complicated because we're looking at all the possibilities. But with these trees, we're really also checking a bunch of different possibilities. We're going to explore more about trees in the future. So this is just a opener of the type of things that you can do with trees. Now, for question number 6, we have, in how many ways can 5 different books be placed on 2 shelves? Specific books must be always next to each other. So now, you're gonna since we have 5 different books, but 2 of those specific books must always be together. So let's think 1, 2, 3, 4, 5. But we're really thinking that this needs to be together. So this is like one big spot, and we're only thinking about four arrangements really. So this is a permutation. So it's 4 ways of arrange 4 places. So that will be 4 factorial, which is 24 arrangements. So that's the total of ways. Now, the 2 books, between them, they can be in 2 different orders, right? Let's say if it's book A and book B, I can have A and I can have B. So in general, the total here is just going to be 4 factorial times 2 factorial, or 2 really. In this case, since that's going to be the ways that I can arrange the 2 books that are fixed. So that will be 24 by 2, and is 48. Okay. Now, question number 7. We have a club with 10 people, and here we must select a president, vice president, and treasurer. And this is all different people. So notice that the order is gonna matter. Is very important if you are being president or by president or treasurer. So here, because the order matter, we're doing a permutation, and we're doing a permutation of 3 people among 10 possible. So this is going to be 10 factorial over 10 minus 3 factorial. And so this is 10 factorial over 7 factorial, which I can see as 10 by 9 by 8 by 7 factorial over 7 factorial, or 10 by 9 by 8. And this is a total of 720 possible slates that we're going to have. Okay, so that was some exercises for counting with permutation and multiplication rule.